But as you think about this exponential growth of data, Ganesh, how is AI's push with this need and demand changing infrastructure as we know it for data centers? I mean, what are people not talking about? What are things that we are just not even, assessing as top of mind for us today?
Right. So I think, like we discussed, in the previous question, the first thing that one needs to know about AI-focused data centers from an infrastructure perspective is that they're centered around the GPU as the backbone computing device, not a CPU. And when you think about it, the reason for that is all of these large language models that are in that are very hot right now. You can abstract the details out, and you can think about them as a series of matrix multiplications, right? And GPUs do that several orders of magnitude more efficiently than CPUs, right? So that choice of the GPU as the compute backbone, that has all sorts of downstream impacts, right? So GPU server racks, for instance, they're far more dense than CPU server racks, and so they consume a lot more power. So if a CPU server rack consumes 10 kilowatt hours of power, GPU server racks consume typically between twice to 5 times of that, right? So 20 to 50 kilowatt hours, right? So you need proportionately that much more cooling capacity to cool GPU computers compared to CPU compute. Now, if you get HVAC systems to do this level of cooling, you just blow cool air over. It's very inefficient. You really have to chill air rapidly, and you then end up spending a lot of electricity and a lot of power, to get the same amount of cooling. So architecturally, you need to move towards different types of cooling systems. Like as a first order effect, that is really different in AI infrastructure, right? So the specific choice of liquid cooling system can, vary, and we go into a lot of detail in the report. But broadly speaking, you can think about closed loop liquid cooling systems, which are extremely efficient, and they bring cooling directly to the chip. So you have a liquid that's in contact with the chip, and you exchange heat with the chip, and then that liquid has to be recirculated. Or you have hybrid cooling systems where you basically blow air through water-soaked pads, and then that exchanges heat with the water, and it's a lot more efficient, right? So those are the two broad categories. Infrastructure-wise, you have closed-loop liquid cooling systems and hybrid cooling systems, right? So in addition to that, when you think about trade-offs when it comes to the infrastructure, if you are a data center operator that already has an established infrastructure, you're going to have to retool that infrastructure in order to accommodate these two different types of toolings. And so that introduces additional amounts of complexity as well, right? So this is not a topic that gets much, airtime when it comes to mainstream discussions. And so, people are singularly focused on, power capacity, as we discussed, and nuclear versus natural gas, or GPU wars between AMD and NVIDIA, right? So, these are extremely important, but there are, cooling technology trade-offs are, extremely important when it comes to AI infrastructure, and they don't get the airtime that they deserve.